Hey Opties! Today we're on Desmos Geometry Tools and we're going to take a look at why side-side angle is not a triangle congruence theorem and also why angle is not a triangle congruence theorem. So we have on our screen here two sides and an angle in that order, and then two sides and an angle in that order for another triangle. And notice we have congruent sides 3 and 4, 3 and 4, and congruent angles 48 and 48 degrees. So I want to show you that these triangles are not congruent. They do look pretty congruent if you're just taking a first glance at them, but let's start by measuring the rest of our angles and we'll see that they're not congruent. So I'll measure this top angle in both triangles, and the first angle is 82 degrees, and let's see what the next one is. It's 86 degrees. So that alone tells us that the triangles themselves are not congruent, because we know that if triangles are congruent, their corresponding parts are congruent. That's CPCTC. Corresponding parts of congruent triangles are congruent. Let's go even further and measure the third angle. That one's 50. This one is 45. So notice we did start with side, and angle in that order being congruent between the two triangles, but it didn't constitute congruence of the whole entire triangles themselves, just those pieces. So that tells us that side, angle does not guarantee congruence for triangles. Now you could have side, angle and it would end up being congruent, but that would just mean that you have to have other information to constitute one of the other triangle congruence theorems. And lastly, let's go ahead and finish up by measuring our third side. That's 3.09, and this one is 2.85. So again, we see they're not congruent. Now we have another triangle that I've created below, and we just have three angles that are marked on this triangle. So I want to show you how I can create another triangle with these exact angle measures that is not congruent to this one. So when we have three angles that are congruent, that actually constitutes similarity, which is something we'll talk more about in the future. And similar figures can, instead of having a rigid transformation, which shows congruent figures, we can do a dilation to show similarity. So what that means is that your side lengths are in proportion to each other. So let me show you what I mean by that. This is a different type of transformation, a dilation is. So we're going to go to Transform, Define Transform, and we're going to click on Dilation. So we want to choose a point or a center that we want to dilate about, and I'm just going to choose a point over here. And let's make our triangle be half as big in our side lengths. So I'm going to put 1/2 for our scale factor. So that means all three of these sides will become half as big as what they already are. And I'll click that triangle because that's what I want to dilate. And when we click apply, we have our triangle. So let's go to construct, and I want to measure these angles. So there's our 47. So we're correct so far on one of our angles. Here's our 51, and of course, because of the interior angle sum being 180, we know our third angle has to be defined, and that's defined at 82. So we see here, we've got another triangle with three congruent angles that's clearly not congruent to our first triangle we had. They're clearly different sizes. And if our side lengths aren't congruent, that means the triangles are not congruent. So these are the two examples of when you have congruent sides and angles and that doesn't constitute congruence. That's side, angle and angle. All right, Opties, that's it for looking at our two examples of congruent sides and angles and showing that it does not make congruent triangles. And again, that's side, angle and angle. See you next time.